Good morning, everyone. Today we are going to start up with the second chapter of electrochemical analysis, that is conductometry. The points to be covered under this chapter is introduction of conductometry, what are conductivity cells, what are various types of conductometric titration, and applications. So before moving on towards the instrumental part of conductometry, let's see introduction of conductometry. So conductometry is nothing but it is the determination of conductance of an electrolyte solution by an conductometer is known as conductometry. That is finding out the concentration of the analyte by measuring the conductance of the analyte is known as conductometry. And the instrument which is used for measuring the conductance of the analyte is known as conductometer. So what is conductance or conductivity? So conductivity is the ability of the solution or ability of the analyte or ability of the metal ion or a gas to pass an electrical current. And from the measurement of electrical current, we can be able to find out the concentration of the analyte. In case of solution, the current is carried by either cations or anions, whereas in metal ions, it is carried out by the electron. So this is the introduction of conductometry. So in conductometry, with the help of conductance of the analyte may be either present in the form of solution or it may be present in either in the form of metal ion or it may be present either in the form of gas. So by the measurement of the electrical conductance of the solution or electrolyte, metal ion or gas, we can be able to find out the concentration of the analyte. So next is how we can measure the conductivity. So conductivity may be measured by applying an alternating electrical current to the two electrodes which is dipped into the solution whose concentration is to be find out. So this is the basic method for measuring the conductivity of the solution. The solution whose concentration is to be find out, we are going to fill up into a beaker. In that beaker, we are going to place two electrodes. By applying the electrical circuit across these two electrodes, there is migration of cations as well as anions towards the respective electrode, and by measuring the electrical current, we can be able to find out the concentration of the solution. So measuring the resulting voltage during this process, we can be able to find out the concentration. So during the migration process, the cations will get travel towards negative electrode and the anions will get travel towards the positive electrode, and the solution will act as an electrical conductor. So this is the measurement of conductivity of the solution. So firstly, in a beaker, we are going to take the analyte whose concentration is to be find out. We are going to convert the analyte into solution form. In that solution, we are going to place two electrodes, that is positively charged and negatively charged electrode, and these two electrodes are connected towards the electrical current. By applying the voltage, due to the application of the voltage, there is migration of anions as well as cations towards the respective electrode, and from the measurement of electrical current, we can be able to find out the concentration of solution. So what is the conductivity of solution? Conductivity is typically measured in aqueous form of solution of the electrolytes. So what are the electrolytes? Electrolytes are the substances containing ions, that is solution of ionic salts or of compounds that ionize in the solution. So ions formed in the solution are responsible for carrying out the electrical current. That ions may be either positively charged or negatively charged. The electrolytes, which includes that may be either acidic in nature, that may be either basic in nature, or that may be present either in the form of salt, or it can be either strong or weak one, that is acidic, basic or salt one. This acidic, basic or salt, that may be present either in the form of strong nature or it may be present either in the form of weak nature. So in case of conductivity of the solution, strong electrolytes or strong ions are the substances that will get fully ionized into the solution, that is it will get easily converted into plus and minus charges, that is the acidic, basic or salts that are stronger in nature, that will get easily converted into fully ionized form. But the acid, bases or salts which are weaker in nature, that are not fully ionized into the solution. Therefore, its conductance will be low as compared to strong electrolytes. So conductivity is the measure of formation of ionized molecule. So in case of analyte, whether it may be acidic, basic or salt, if it is stronger in nature, then conductance will be more due to the formation of fully ionized positively charged and negatively charged substances as compared to weak electrolytes. In case of weak electrolytes, they are not fully ionized present. So therefore conductance will be low for weaker electrolyte as compared to stronger electrolyte one. So next is the instrumentation of conductometer. For determining the conductance of the electrolyte solution, the instrument is categorized into conductivity cell and conductometer. So depending upon the nature of analyte, this conductivity cell is further categorized into three types, that is wide mouth cell, that cell for reaction producing precipitates, and deep type cells. So what is conductivity cell? The conductivity cell, it is made up of pyrex or quartz and are fitted with two platinum electrode, that is one will act as an anode and another will act as an cathode, and it should be placed in a vessel containing water to maintain the temperature constant. So depending upon the nature of analyte, this conductivity cell is categorized into three classes, that is wide mouth cell, cell for reaction producing precipitate, and dip type cell. So let's see one by one. First type of conductivity cell is the wide mouth cell. So it is a wide mouth bottle with a bark cork having holes for passing the two platinum wires, which is having a size of 1 square centimeter, and it is used for conductance of low measurement. So here is the picture of wide mouth cell. That is, it is a vessel made up of pyrex. It contains the solution whose concentration is to be found out, and two holes are present. With the help of these two holes, we can be able to place two platinum wires inside it. And it is particularly used for determination of the electrolytes that are having low conductance. Next type of conductivity cell is the cell for reaction producing precipitate. So in that, the electrodes are tightly set in the perpex lid, which is provided with opening for stirrer and tip of the burette. Since this second type of conductivity cell is used for determining the concentration of precipitate, a certain stirrer should be inserted into that conductivity cell. So for placing the stirrer, a separate hole is present, and magnetic stirrer is used for stirring the solution of the precipitate, and it is particularly used for precipitating type of conductance. Say for example, the analyte containing halide atoms that will get converted into precipitate form. So here is the picture of second type that is particularly used for precipitating type of reaction. Here it is a vessel which is made up of pyrex. In that vessel, two electrodes are present, that is platinum electrodes, and a separate hole is present, and through that hole a magnetic stirrer is inserted that will stir out, or that will properly mix out the formed precipitate of the electrolyte. Third type of conductivity cell is the dip type cell. It is a wide the bore glass tube of coring glass are fixed with the copper wire. So with this platinum wire, they are fixed with the help of the copper wire, and the tip of which has two platinum plates of 1 square centimeter in a size, and which is fixed at 1 centimeter distance, and the terminal of copper wires are taken out for the connection with that of the voltage, and the position of wire is fixed in a glass tube by rosin. So this is the dip type cell. In dip type cell, there are two electrodes which are placed at a distance of 1 centimeter, and the platinum plates are which are placed at the distance of 1 square centimeter size. So these are the three types of conductivity cell. First type is wide mouth. It is particularly used for determining the concentration of the electrolytes that is having low conductance. Second type, it is particularly used for determining the concentration of the electrolytes that will get converted into precipitate form. And third type is the dip type cell. In case of dip type cell, the two platinum electrodes are connected towards the copper one. So these are the types of conductivity cell. Second instrumentation part of conductivity cell is the conductometer. So conductance measurements are made by using conductivity bridge. So conductometers are made using Wheatstone bridge circuit. So this is a Wheatstone bridge circuit for conductometer. In this, the cell is placed in one arm of the Wheatstone bridge circuit, that is A and B. A and B represents the cell, that is anode and cathode, and R1 are composed to the arm AC. So what does this R1 represent? R1 represents the resistance. Next is the D. D stands for the detector. The detector may be either galvanometer or earphone, and a source of alternating current, that is V, which with a frequency of 50 to 60 hertz is used in circuit by connecting B and C. So this is the diagrammatic representation of conductometer. So what does conductometer comprises of? Conductometer comprises of the firstly cell, which is attached in between A to B. Nextly resistance, which is attached in between A and C. Next is the detector. The detector may be present either in the form of galvanometer or it may be present either in the form of earphone. And lastly, it comprises of the alternating current, that is capital V, with a frequency of 50 to 60 hertz and which is connected with the Wheatstone bridge with the help of B and C. So this is the conductometer. So with this, we have completed instrumental part of conductometer. Conductometer comprises of mainly conductivity cell. So depending upon the nature of analyte, this conductivity cell is categorized into three types, that is wide mouth cell and cell for reaction producing precipitates and diptide cells. In these three types of conductivity cell, there is presence of two platinum electrodes which is dipped into a vessel containing a solution whose concentration is to be determined, and these two platinum electrodes are connected towards the electrical circuit. Second instrumentation part of conductometer comprises of the Wheatstone bridge. In that Wheatstone bridge, firstly cells A to B cell is present. Nextly resistance, that is R1, it is represented in between A to B represents the cell, A to C represents the resistance, D represents the detector, and V represents the alternating current. Next major part of conductometer is the conductometric titration. Depending upon the nature of analyte, whether it is acidic, basic or salt, and whether it is stronger in nature or weaker in nature, conductometric type of titration is categorized into four major classes. So firstly, we will see what is conductometric titration. So conductometric titration, it is a laboratory method of quantitative analysis used to identify the concentration of given analyte in a mixture. So whatever may be the mixture present into an analyte, we are going to perform the titration procedure, and with the help of electrical current measured by the titration, we can be able to find out the concentration of analyte. So what is the principle of conductometric titration? During a titration process, one ion is replaced with another. That is when we are going to transfer 1 ml of standard solution from burette to contents in conical flask, there is replacement of ion between the titrate and titrant, and the difference in the ionic conductance of these ions directly impacts on the overall electrical conductivity of the solution. And it can also be observed that the ionic conductance values varies between the cations and anions. That is, what is the nature of the anions and cations, whether it may be stronger or weaker in nature. Depending upon the nature, its conductivity varies. And finally, the conductivity is also dependent upon the occurrence of a chemical reaction in the electrolytic solution. So conductivity titration mainly depends upon the concentration of analyte, that is whether in what concentration they are present, and what is the nature of analyte, that is whether it is present in a stronger nature or weaker one. So this is the principal part of conductometric titration. Conductometric titration are similar to that of volumetric titration, but the major difference between conductometric titration and volumetric titration is, in case of conductometric titrations, we are going to measure the electrical conductance of the analyte, that is either cation or anion, and if the nature of analyte it is stronger, conductance will be more, and if the nature of cations or anion is weaker one, conductance will be lower one. So how we can define the titration? So this is the basic concept of titration procedure. So in case of titrometric analysis, The solution whose concentration is known to us, that we are going to fill up into the burette, and that solution is known as titrant. Next is the solution whose concentration is to be determined, which is also known as titrate or annulate, which it is present into the conical flask. So dropwise we are going to add 1 ml of standard solution from burette to contents in conical flask up to when completion of reaction occurs. But in case of titrimetric analysis, completion of reaction between titrate and titrant can be indicated by the color change of indicator. But in case of conductometric titration, from the volume or from the conductance of the electrical conductance of the annulate, we can be able to determine the concentration. So this is the basic titrimetric part of volumetric as well as conductometric analysis. That is, we are going to add 1 ml of standard solution from burette to contents in conical flask until completion of reaction has been occurred. In case of titrimetric analysis, color change of contents in conical flask indicates the end point of titration. But in case of conductometric type of titration, end point of titration can be determined by plotting a graph. That comes under titration curve. So firstly, we will study types of conductometric titration. So conductometric types of titration is categorized mainly into 4 classes depending upon the nature of annulate, whether it is strong or weaker in nature. So first class of conductometric titration is the titration of strong acid with strong base. Best example is the titration of hydrochloric acid with sodium hydroxide. Second type of conductometric type of titration is the titration of strong acid. Say for example, hydrochloric acid with a weak base, that is ammonium hydroxide. Third type of conductometric titration is titration of weak acid, that is CH3COOH with strong base, that is NaOH. Next is the titration of weak acid with weak base, that is CH3COOH with NH4OH, that is ammonium hydroxide. So depending upon the nature of the annulate, whether it is strong or weak, conductometric titration is categorized into 4 classes, that is strong acid versus strong base, strong acid versus weak base, weak acid versus strong base, and weak acid versus weak base. So let's see one by one various conductometric titration. Before studying conductometric titration, we should know what is titration curve in conductometric titration. So in case of conductometric titration, a titration curve is drawn by the volume of titrant consumed by annulate with that of the pH of the annulate. So titration curve, it is a plot of pH of annulate. That's annulate is nothing but the solution whose concentration is to be find out. So from a pH of the annulate versus volume of titrant consumed by the annulate, a titration curve is drawn. And from the titration curve, we can be able to find out the end point in conductometric type of titration. So let's attempt to draw some titration curves. That is, first type of conductometric titration is the titration of strong acid with strong base. Best example is titrating HCl with sodium hydroxide. So various types of acids and alkali titrations are carried out using conductometry. Some typical conductometric titration graphs are obtained, which are shown over here. So first is the strong acid with strong base. So in case of titration curve, we are going to plot the graph of volume of titrant consumed by annulate towards the pH of annulate. So in case of strong acid with strong base, in this titration, that is hydrochloric acid with sodium we are going to titrate hydrochloric acid with sodium hydroxide. So initially there is fall in conductance is obtained due to the replacement of the hydrogen ions of high ionic mobility with slow mobility sodium ions. But after the endpoint, the conductance rises due to the excess of hydroxyl ions being added. So shape of the graph for strong acid with strong base is depicted over here. So initially there is fall in conductance of the HCl. The fall occurs due to the ionization of HCl, that is H into H plus plus Cl minus, and this H plus will then replaced with the Na. So due to the presence of Na into the conical flask, there is fall into the conductivity of the annulate. But as we are going to add 1 ml of sodium hydroxide from burette to contents in conical flask, volume of hydroxyl, that is OH minus, will get increased into the conical flask. And finally, the conductance of OH is greater as compared to the conductance of the ionized H plus. Therefore, there will be rise in conductance. So this will be the graph for strong acid versus strong base type of titration. Initially, there will be fall in conductance due to the replacement of the H plus with Na minus. Na is having less conductivity as compared to H plus. In case of any sort of conductometric type of titration or titrometric type of titration, there is replacement of the ions when we are going to add 1 ml of standard solution from burette to contents in conical flask. So initially, in case of HCl, contents in conical flask will be only HCl. So conductance will be only due to the presence of the H plus. But when we are going to add 1 ml of sodium hydroxide from burette to contents in conical flask, this H plus will be replaced with NaOH. But a point will come when all of the HCl has been neutralized by NaOH, and there will be excess drop of NaOH into the conical flask. So due to the excess amount of sodium hydroxide into the conical flask, there will be rise in conductance, and that is depicted into the graph. And the graph for strong acid versus strong base will be appear. Initially there will be decrease, and finally there will be increase. Decrease in conductance is due to the replacement of H plus with that of the Na, and increase in conductance will be due to the replacement of the Na with that of the OH. So increase in conductance is due to the presence of excess drops of the hydroxyl ion. Hydroxyl ion will be having more conductivity as compared to ionized H plus 1. Next type of conductometric titration is the titration of strong acid with weak base. Example is either titration of hydrochloric acid with ammonia. So the progressive fall in conductance is due to the disappearance of the hydrogen ions of high conductivity hydrochloric acid, that is high ionic mobility during the neutralization. And after the endpoint, that is when all of the HCl has been consumed by ammonia, the graph will become almost horizontal because of ionization of ammonia is prevented in presence of ammonium chloride or ammonium sulfate formed during the neutralization. So initially there will be fall in conductance. Fall in conductance is due to the replacement of the high conductivity HCl with that of the ammonia. And after the end point, what does this point represent? That is the equivalence point of titration. That is all of the high conducting HCl has been replaced with ammonia. And this line represents the ionization of the ammonia. So this will be the graph for strong acid with weak base. Example is titration of HCl with that of the dilute ammonia. Third type of conductometric titration is with weak acid with strong base. So for weak acid with strong base, the titration of weak acid like acetic acid or boric acid with strong base, say for example sodium hydroxide, the shape of graph will depend upon the concentration and dissociation constant of the acid. So thus in the neutralization of acetic acid, initially there is ionization of acetic acid. Due to ionization, there will be decrease into the conductance. Conductance is due to the ionization of small amount of acetic acid, but upon the progression, salt formation increases. That is all of the acetic acid, it will get consumed with that of the strong base, that is sodium hydroxide. Due to the consumption of the weak acid with strong base, there will be rise in conductance. Rise in conductance is due to the presence of OH entity of the strong base, that is sodium hydroxide. So these two opposing influence show fall followed by rise in conductance. After the neutralization, there is break. That is, this point indicates the neutralization. There is break indicating rise in conductance due to the hydroxyl ion. A shape of graph is shown in figure. So this will be the graph for weak acid with that of the strong base. Initially, there will be decrease in conductance. Decrease in conductance is due to the dissociation of the acetic acid, and increase in conductance. But when all of the acetic acid has been consumed with that of the strong base, that is sodium hydroxide, then when excess amount of strong base we are going to add from burette to contents in conical flask, there will be rise in conductance. This rise in conductance is due to the presence of the hydroxyl ions of the strong base, that is sodium hydroxide. So this point indicates the end point of titration, that is all of the acetic acid has been consumed by strong base, that is sodium hydroxide, and rise in conductance is due to the excess drop of sodium hydroxide added from the burette. Fourth type of conductometric titration. Fourth type of conductometric titration is titration of weak acid with weak base. Say for example, titration of acetic acid or phenol with a weak base, that is aqueous ammonia. And the graph of weak acid with weak base is depicted over here. The neutralization curve up to end point of weak acid is similar to that obtained with the sodium hydroxide. So conductance rises due to the salt formation of weak acid. So there is rise in conductance. Initially, there will be conductance due to the ionization of weak acid, that is due to the ionization of either acetic acid or phenol. But after the end point, when all of the acetic acid has been consumed with the weak base, there will be formation of the straight horizontal line. So after the equivalence point, an excess of aqueous ammonia solution has no effect upon the conductivity, and because of suppression of ionization of ammonia by the salt formation. So these are the four types of conductometric titration. We'll cover up the summarization part as well as application of conductometric titration in next class.